So today we will learn about the ventricular system. According to the National Medical Commission prescribed CBME guidelines, according to the competencies, AN 63.1, that is anatomy 63.1 competency mentions that a student needs to know to describe and demonstrate the parts, boundaries and features of the ventricles, that is the third ventricle, fourth ventricle and the lateral ventricle. So it is a competency prescribed as a necessity by the National Medical Commission of India. Now, so we need to know what are ventricles. So first we will get an overview of what these ventricles are. As you can see in this image, in that dark brown structured, that colored structure within the brain, that is called the ventricle. So what are ventricles? Ventricles are basically spaces. These spaces are filled with CSF. So they are CSF filled spaces that are present within the brain. Here you need to know that outside the brain also there is CSF. Cerebrospinal fluid is there outside the brain as well as inside these cavities called the ventricles. Okay, so CSF is present outside the brain as well as inside the brain within the ventricles. So we need to know the ventricular anatomy in detail for this. So this image, we'll survey through this image to understand an overview about what these structures are. First of all, you have two large lateral ventricles. You can see two large lateral ventricles, C-shaped lateral ventricles that are present here, which has several projections. You can see a projection over here, a projection over here and a projection over there. Okay, so that C-shaped enormous ones, they are the largest of the ventricles and they are called lateral ventricles. As you know, the lateral ventricles are present in the cerebral hemispheres. You know already that cerebral hemispheres are two in number. So just like that, the lateral ventricles are also two in number. So you have two C-shaped lateral ventricles and they are the largest ones and they are located within the cerebral hemispheres. Now between and below these two lateral ventricles, okay, I forgot to mention, this is one lateral ventricle and this is the another lateral ventricle shown in that image. Now between these two lateral ventricles and below these lateral ventricles, you can see another ventricle and that is called the third ventricle. Okay, third ventricle is a single ventricle and that is present in the diencephalon. Okay, diencephalon is another part of the brain. The diencephalon part of the brain is relatively hidden. You can't see the diencephalon very clearly when you examine the brain from the outside. Okay, that is between and the name diencephalon means between brain. So it is located a little bit hidden within the core of the brain. So within the diencephalon you have the third ventricle. Now the third ventricle then communicates into the fourth ventricle. Fourth ventricle is what you are seeing here. In this lateral projection view, you can see that fourth ventricle is appearing something like a tent shaped cavity. Okay, a triangular shaped cavity, a tent shaped cavity, that is the fourth ventricle. So altogether you are seeing there are four ventricles, that are two lateral ventricles present inside the cerebral hemisphere. The diencephalon, a single diencephalon contains the single third ventricle and a single fourth ventricle located within. This part is called the hindbrain. This is called the hindbrain. Okay, now I'll just detail a little bit about the communications between these different cavities. Okay, the two lateral ventricles are not communicating with each other, but they are communicating with the third ventricle. Okay, and that is called, okay, let me just clear this annotations off, and that is called the foramen of Monro. Okay, foramen of Monro. You can see this small canal, that is called the foramen of Monro. This is another foramen of Monro. So you have two lateral ventricles and the two lateral ventricles will be communicating through two foramen of Monro into the midline third ventricle. That is what you are seeing here. Okay, so foramen of Monro are basically two in number. Okay, they are basically two in number and the two are located just close to each other near the midline and they will be communicating the lateral ventricle to the third ventricle. Now the third ventricle, as you know, it is seen in the diencephalon. The third ventricle is communicating with the fourth ventricle through the aqueductus sylvius. Now let us have a look where the aqueductus sylvius is. This long tube that you are seeing here is called the aqueductus sylvius and that is communicating the third ventricle, which was this structure, with the fourth ventricle. Okay, this is the third ventricle, this is the fourth ventricle. So that is how the ventricular system will communicate with each other. Now one more point I need to detail. I told you already that the lateral ventricle is present in the cerebral hemisphere. The third ventricle is located within the diencephalon. Now, where is the fourth ventricle located? The fourth ventricle is located behind the lower part of the brainstem. This bulge is called as the pons, P-O-N-S, and this is called as the medulla, okay, medulla. And this small structure that you see behind and below the cerebral hemispheres, that is called as the cerebellum. Now, the fourth ventricle is therefore located behind the pons, behind the medulla, and in front of the cerebellum. So, the location of the fourth ventricle and its relations with the different parts of the brain are very important. Okay. So, this is the overview about the ventricular anatomy proper. Now, let us have a look about how I told you that this is containing CSF, and it is communicating with the CSF that is present outside the brain. So, let us have a look at how that is occurring. This is a physiology integration topic, and this is called the CSF flow within the ventricular system. Okay, the ventricular system contains a structure called choroid plexus. That is what is shown in this red color. Okay, that is the choroid plexus. Now, the choroid plexus is a structure that will produce the CSF from the vascular system. So, from the blood, the CSF is produced by the choroid plexus within the lateral ventricle, as well as the minimal amount by the fourth ventricle, but mainly by the lateral ventricle choroid plexus. So, that will produce the CSF. So, you can see that the CSF will be filling the two lateral ventricles, as you can see in these arrows, and they will flow from the lateral ventricle through the foramen of Monro into the third ventricle. That is why you need to know the communications of these ventricles, and that is the third ventricle now. So, the CSF has reached from the lateral ventricle, it has gone through the two foramen of Monro into the third ventricle, and from the third ventricle it will communicate through the aqueductus sylvius into the fourth ventricle. Okay, this is the fourth ventricle. From the fourth ventricle, the CSF will drain into the subarachnoid cisterns. These are called the subarachnoid cisterns, and thus into the subarachnoid space. Through these three communications. These three communications are the foramen of Magendie and the foramen of Lashka. Let me remove these annotations to make this clear. You have a midline foramen of Magendie, okay, Magendie in the midline, you can remember like that, M for M, and L, Lashka, lateral apertures, they are located laterally. Okay, so you have two lateral apertures and one midline aperture through which the fourth ventricular cavity will be communicating with the subarachnoid cisterns. So, this is the basic ventricular anatomy, and any blockage of any of these communications, for example, if you have an obstruction in the aqueductus sylvius, or you have an obstruction in the foramen of Monro, it can cause damming up of CSF within the cavities and can cause enlargement of these cavities. This is called as hydrocephalus. Hydrocephalus is a clinically important condition where this ventricular anatomy is very, very important. Okay, suppose you have a lesion that is affecting this drainage system, then the entire ventricular system can be dilated with CSF, and eventually the CSF will be drained through these structures. These structures are called as the arachnoid granulations. So, it is through the arachnoid granulations that the CSF will drain out from the subarachnoid space back into, okay, you can see this white arrow, it is draining through this arachnoid granulations back into the dural venous sinuses. That is how the CSF that came from the choroid plexus from the vascular channel will eventually drain back into the blood through the dural venous sinus. Okay. This is the basic understanding about the ventricular system. With this, we will have a look at the spatial understanding of this ventricular anatomy in more detail in a tool called AnaView. Okay, now you are seeing this tool. This tool is called AnaView. This tool has a 3D interface. What you are seeing here is the 3D interface, and on this side, that means on the right side of the screen, you are seeing three panels. Okay, these three panels are the canonical views that you see in radiology. Okay, for example, this one that you see is an axial section or the horizontal section. This one that you see is a coronal section, that is a plane that goes like this. Okay, that will divide the brain or the head and neck into an anterior and a posterior parts. And this is a sagittal section that goes like this, that will divide the brain into left and right parts. And the flexibility of this tool is that you can rotate this 3D viewport into any view that you want. Okay, for example, you are now seeing the ventricular system anatomy, and you can view it from any part that you want to understand the anatomy in much detail. And you can move these planes into any plane that you want to see how these structures will be appearing in a sectional view. For example, in a coronal image, you can see how the ventricular system is located in this image, or in a sagittal image, you can zoom in and you can see how the ventricular system will be looking in a sagittal image. So this is the capability, the flexibility of this tool. And with this, we will have a look at the ventricular anatomy in this view, okay, in the sagittal view. I am moving this plane to make it a little more clear. Okay, you can see the two lateral ventricles. Okay, can you see the two lateral ventricles? What you see as blue are the two lateral ventricles. You can see that is a very enormous, it is C-shaped lateral ventricles. It has different projections. This is the anterior horn, the inferior horn, the posterior horn. I will come to that details in a lateral ventricle session. But eventually you can see that the lateral ventricles are located within the cerebral hemispheres. You can see that very clearly here, right? This is the coronal section, and you can see that coronal section view you can see here, and you can understand that this is the CSF filled ventricular cavity, the lateral ventricle cavity, and you can see that in this coronal image. And you can move this to a front plane, and you can see how this lateral ventricle is appearing in this coronal section. You can see this dark colored cavity that you see here is that they are the lateral ventricles. You can see how close two lateral ventricles are. So all of this is visible when you can move these planes to front and back. Okay, now I am moving this in the side view for you to understand how the C-shaped cavities are communicating to the midline third ventricle. You can see the midline third ventricle that was located within the diencephalon. So that midline third ventricle is communicating with the two lateral ventricles through these two small channels, through these two small canals, and they are called as the foramen of Monro. So the foramen of Monro is communicating the lateral ventricle into the third ventricle. The third ventricle is a single cavity in the midline, and the lateral ventricles are two enormous cavities in the cerebral hemispheres. And you can see the third ventricle is having different pockets. We will come to that details in the when we learn about the third ventricle in detail later. And you can see a large hole inside this third ventricle. Is it seen? It looks like a big perforation inside that. Okay, that we will come to that details later when we learn about the third ventricle. But here you can see that if I move the axial plane more downwards and the coronal plane more backwards, you can see how the ventricular system, the fourth ventricular system is there. Okay, this is the fourth ventricle cavity, and the fourth ventricle cavity is located behind the pons and the medulla and in front of the cerebellum. What you are seeing here is the cerebellum. Okay, this section that you see here, that is a cerebellum. In front of that you are seeing the pons and the medulla. I will just move the sagittal plane into this fourth ventricle to make that very clear. Now you can see how clearly you can see the pons in front and the medulla below, and the cerebellum is located behind, and between that you are seeing the fourth ventricle. Okay, now you can see this long tube. That long tube is nothing but the aqueduct of Sylvius. The aqueduct of Sylvius is actually passing through this structure, and that structure is called the midbrain. Midbrain, pons and the medulla is together forming the brain stem. Okay, and behind the pons and medulla you are having the fourth ventricle, and through the midbrain you are seeing the aqueduct of Sylvius that is communicating the third ventricle, which is in the diencephalon, to the fourth ventricle, which is in the hindbrain. The hindbrain is the pons plus medulla plus the cerebellum. Okay, so altogether I gave an overview about the ventricular system through different perspectives, not only in the 3D perspective, in the sectional view, in the diagram, but also in scans, how we can identify these structures in scans as well. Now I will just remove this, remove this 3D model. Okay, I will remove this 3D model and make only the planes visible. Now what I'll do is I'll just remove these planes and I'll make this 3D model alone visible. This was what we saw earlier. You can see the two C-shaped lateral ventricle, the third ventricle in the midline, which is in the diencephalon, the aqueductus sylvius passing through the midbrain, and the fourth ventricle, which is behind the pons and the medulla and in front of the cerebellum. So you understood how the ventricular system is arranged, ventricular anatomy is arranged, and how they are related to different parts of the brain. Okay. So that completes the overview of the ventricular system. I hope the session was understandable, and we will learn in detail about the lateral ventricle and the third ventricle in the coming session.